Okay, DC circuit part 1. Okay, in this first part, we'll be covering both 17.1 and 17.2. We will discover how does the current, potential difference, and resistance vary in a series and in a parallel circuit. Okay, so these are the learning outcomes for 17.1. Okay, so in the previous section, we did learn that we often use circuit symbols to simplify an electric circuit. So we draw circuit diagrams with circuit symbols. So over here, you have a whole list of the symbols that you need to know. What do they represent in a circuit diagram? The first one, okay, is actually a switch. And then the second one over here is actually a cell. You have a long line and a short line. The long line represents plus and the short line represents minus. Okay, in exam, the plus and minus might not be shown, but you must know that the long line represents the plus and the short line represents the minus. Okay, and then when you have two or more cells together, it's called a battery. Okay, and next, when you see this, it's actually called a DC supply. Okay, means that the current only flows in a single direction. And when you see this, it actually means an AC power supply, which means that the current flows in changing direction. First, it flows from left to right, and then later it flows from right to left. Okay, so the direction of the current keeps changing. Next is common, it's called light bulb. And then these two will be learned in this chapter later on. Okay, so you have this is called a potentiometer where you can change the potential difference. Okay, and then you have this, okay, it's called a light dependent resistor. You have light falling onto it. So this resistance is dependent on the amount of light falling onto it. So it's called LDR in short. Okay, and then next we have this, okay, which means that you have wires joining. And when you see there's a bump over here, it means that the wires are not joined. Okay, the wires are independent of each other. They just put one on top of each other, but not joined. Okay, and then this one is what we have covered previously. This is a fixed resistor. Okay, and then with an arrow is a variable resistor, or we call it a rheostat. And next we have a rectangle box, but with a wire in between. It's actually a fuse. And this is a coil wire, this is a transformer, this is a diode, this is a galvanometer. Okay, some of these are new because you have not learned it, but you will be learning all of this soon. Okay, and then next few you should know is an ammeter to measure the current, voltmeter to measure the voltage or potential difference. And then this is actually a two-way switch. I can close the switch to the top or I can close the switch to the bottom. Okay, and then there's three lines getting shorter and shorter. It represents earthing. And then this one is actually looking like a diode, but with arrows. So it's actually still a diode, but it's a light emitting diode, or in short, we call it the LED. Okay. And then next we have the thermistor, okay, which we will cover in this chapter as well. And lastly, the bell. Okay, so let's take a look at a series circuit. Okay, you must know that in a series circuit, the components are connected one after another in a single loop. There is only one path. Okay, and there are three main ideas for a series circuit. The three main ideas are, the first idea is that the current at any point is always the same. Okay, and then the second idea is that the potential difference by the supplied by the battery will be shared across the components. And lastly, the total resistance of the circuit, or we call it the effective resistance of circuit, is equals to the sum of the individual resistance. Let's go into each one of these three main ideas individually. Okay, so the first one, in series circuit, because there is only one path for the charges to flow. Okay, so in this case, the current is flowing out of the battery, pass through A1, pass through R1, pass through A3, pass through R2, pass through A2, and back to the battery. There's only one path for the charges to move, and the charges do not get used up. Okay, so the current at any point in a circuit, in a series circuit, will be the same. So we have A1 is equals to A3 equals to A2. Okay, so if I have 3 ampere flowing out, I will have 3 ampere flowing through here and 3 ampere flowing through here. Any point in the circuit, it will be 3 ampere. Okay, next, okay, if the current is the same, the potential difference will be shared. Okay, so in a series circuit, the battery provides me with a certain amount of potential difference or EMF. Okay, and this EMF will be shared across all the components. So if, for example, my EMF for my battery is 10 volts, okay, and R1 takes up 3 volts, then the rest of the 7 volts must goes to R2. Okay, the voltage gets used up or the energy gets used up in the circuit. So if it's 10 volts here, it'll be 3 volts here, it'll be 7 volts here. If it's still 10 volts here, this one takes 6 volts, this one will take 4 volts, etc. Okay, so it will be the voltage in the battery will be shared across the components. Okay, and then lastly, the resistance. Okay, resistance in series will be just adding the individual resistor. So for example, in this case, there's 2 resistors. So the total resistance, or we call it the effective resistance of circuit, will just be R1 plus R2. It will just be the sum of both of them. Just take note that if I add one more resistor, which is in series again, then the total resistance will be R1 plus R2 plus R2. So adding resistors in series will actually increase the total resistance of the circuit. Okay, let's move on to do some questions. Over here, I have 2 resistors connected in series. You may pause the video now to think about the answers to these 3 questions. Okay, I'm going to go through the answers now. Is the current flowing through the 2 resistors the same? The answer is yes, because they are in a series circuit. So in a series circuit, there's only one path for the charges to flow. So at any point of time, at any point where I use an ammeter to measure, the current will all be the same. Okay, because charges cannot be used up. 5 ampere flow out of the battery, 5 ampere must goes back into the battery. Next, what happens to the current in the circuit if one of the resistor is removed? So now there is 2. If I were to remove one of the resistor, then I would have decreased the total resistance of the circuit. If I have lesser resistance in the circuit, more current will flow. Okay, or there will be an increase in the current. So then the next question comes where I have what would happen to the current if one of the resistor has a resistance that is twice that of the others. So initially, maybe I have 1 ohm, 1 ohm. Now I have one that is twice. So it becomes 2 ohms and 1 ohms. So I'm actually increasing the resistance of one of them. So when I increase the resistance, my total resistance will be the sum of these two. So my total resistance will actually increase. And if my total resistance increase, my current flowing through the entire circuit will decrease. Okay, let's move on to a parallel circuit now. Okay, so these are the learning outcomes for parallel circuit. Okay, again, for parallel circuit, there are 3 main ideas. We are again going to zoom into how is current, how is potential difference, and resistance in a parallel circuit. So these are the 3 main ideas. The first one, okay, is exactly opposite of series. In a series, the current is the same at every point, but in parallel circuit, the current will be split into the individual branch. So the current will be shared across all the branches. Okay, next, for series circuits, the potential difference will be shared. But in parallel circuits, the potential difference across the branch will all be the same. Okay, and lastly, for series circuits, okay, the total resistance will just be the sum of the individual one, R1 plus R2. But for parallel circuits, okay, we always take the reciprocal of the effective resistance. So it's 1 over R equals to 1 over R1 plus 1 over R2. Okay, let's zoom into each one of them individually. Okay, so you can take a look at this. I have 2 resistors that are connected in parallel. Okay, they are parallel because they are in separate paths. Okay, they are not connected in a single loop side by side. They are connected in a separate path. I can have current flowing through the top path through R1, or I can have current flowing through R2, or I can have current flowing through both R1 and R2. Okay, so there's more than one path for the charges flow. Okay, so if there is more than one path, the current will flow out of the battery, and at this junction X, the current will split up. So when the current splits, voltage remains the same. Okay, so A or I equals to I1 plus I2. And then for parallel circuits, okay, because the current split, the voltage will be the same. Okay, so if my battery is 10 volts, then across R1 will be 10 volts, across R2 will be 10 volts. Even if I put 10 more resistors in parallel, the total resistance across will all be 10 volts. Okay, irregardless of the number of resistors in parallel. Okay, the voltage will always be the same. And then lastly, how do I calculate? How do I combine these two resistors in parallel together? I will need to take 1 over R equals to 1 over R1 plus 1 over R2. Okay, later on we'll show you some examples of that. Okay, so just take note, because I'm taking the reciprocal, if I have one more resistors added in parallel, I have R3 added in parallel, then my total resistance will be 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3. So if I add resistors in parallel, I would have decreased the total resistance of the circuit. Okay, it's exactly opposite of series. Series, I add one more resistor, my total resistance increase. But for parallel, when I add one more resistor, the total resistance will decrease because I'm taking the reciprocal of it, 1 over R. Okay, so I can combine these two to give me an effective resistance as a single resistor over here. Okay, let's move on. Okay, so we have covered the 3 rules about current, potential difference, and resistance in series and parallel. That is all for part 1.